All right, welcome everybody. We're going to go ahead and walk through the lab we did today for our virtual students. So we are working right now on a lab called Enthalpy of Combustion lab. So the way this works is there are two parts to this little guy. We've been talking lately about calorimeters, how we can collect the energy from a chemical reaction, the heat that is given off by the chemical reaction, get it absorbed by water. And then we can calculate how much energy goes into the water, and based on that, we can find the enthalpy change for a chemical reaction, like this little guy up here. So there's two parts to it. First thing we're going to do is we're going to burn some ethanol, and I'll show you the setup in a minute. We're going to burn some ethanol. We're going to collect all of the heat in a little soda can filled with water, a calorimeter. And then based on what we've been doing, we can solve for our enthalpy change here. Not too bad. The way we'll do that is using some of the equations we've been playing around with. Q equals mc delta T. So we'll look at the mass of the water, how many grams we have. C is 4.18, one of those numbers off your formula sheet. Then we'll look at the change in the temperature of the water at the very beginning, before the combustion occurs, and then it should heat up as this alcohol is burning. Then we can get our change in temperature and determine how many joules of energy was absorbed by that water. And then for us to be able to solve for enthalpy change, we'll go ahead and see how many grams of ethanol reacted during this chemical reaction. We'll be able to work through the math. Our unknown be our enthalpy change. From this data up here, the amount of energy that's absorbed by the water, we can take this number, drop it on down here, and we'll make the assumption, although it's not a very good one, we'll make the assumption that all of the heat from this chemical reaction was absorbed into the water. So since the direction of heat transfer was different, we're actually going to take this Q number here, we're going to drop it down here, but we're going to change the sign. We're going to make it negative, and because of the way that we'll calculate this, this is actually going to be in joules, and we'll want to turn it to kilojoules. So on our way down there, we're also going to divide it by 1,000. All right, the worksheet you're looking for should be under the assignment section. I'll go ahead and share it on the screen in just a second, and I'll show you our setup. All right, it's this little guy right here. So make sure you've downloaded this. We've got a procedure here, but I'll be walking through it, and I've made some changes to it. For our first trial, we'll be using the alcohol. It's not going to let me highlight it. We'll be doing everything in this first column here. We'll be combusting some ethanol, figuring out the enthalpy change on the back as you walk through all these questions. And then over here, for trials 2 and 3, we will be burning a chip, and we will see how much energy is released by that. We can go ahead and convert the energy released by that burning chip into joules, and we can compare it to the nutritional label and see how close we can get to, well, the amount of energy in that chip. Let's see, stay with me for a little bit. The production quality isn't going to be great on this, but that's how it goes. This is my first round of giving this a try. All right, so let's go ahead and walk through our setup for a second. All right, so here's where the reaction is going to occur. We've got, I'll rise this up a little bit. So first off, we have the alcohol in this little guy. This little thing's called an alcohol burner. And we typically see these in a chemistry class when we don't have Bunsen burners. And since our gas is turned off to this classroom, we'll be using these every once in a while if we want to at least slowly heat something. So it is full of ethanol right now. And so slowly some of the ethanol will be kind of wicked by a little string that's going through up here. And so right now I'm actually burning the ethanol that I placed inside of this. I'm going to be using that to heat up this water here, and I'm going to measure the amount of ethanol I use. So how are we going to do that? Well, let me show you. We got some data to collect first. This can up here, this can is filled with water, about halfway filled with water. We'll go ahead and weigh this, and this is going to be our actual calorimeter. I'm going to be stirring a little thermometer around in here to determine the temperature change, and we'll record that data on that little data table on our worksheet. All right, let's go ahead and get started. All right. Hopefully this is in focus, but honestly, it doesn't look too great, but I think you can follow along if you're listening to the words. All right, here's my calorimeter. Right now, this is just an empty soda can. I need to go ahead and determine the mass of that. All right, so I get a mass of 12.72 grams. So that's going to be my first column. Now I need the mass of my calorimeter plus water. So this is the can I will actually be using. It's about half filled with just normal tap water. All right, so I'm getting a mass of 125 point, let's go 38 grams. All right, this is absorbing my heat. I'll go ahead and set this over here on my setup. Now I've got my calorimeter filled with alcohol, the ethanol I'm using. Got the mass of that before combustion, 170.25. Now I'm going to go ahead and burn this for about 30 seconds and try to funnel all the heat up into the soda can. And hopefully when I weigh this thing again, the mass will drop. It won't drop very much, but however much less it weighs after the reaction, well, that's how much ethanol, that's how much alcohol I used up. All right, so let's switch screens and come back over here. Real quick, before I do that though, better determine my temperature of this little guy. Stir around for a second. I don't know if you can see, but it shows my initial temperature is 24.7 degrees Celsius. 24.7 degrees Celsius. All right, that's what looks like all I need before I start this reaction. All right, put this up here. Maybe I can move it back so you get a little bit better view. Put this guy under here, and I'm about ready to go. Let me go ahead and lower this down a little bit. Now, this is a pretty rudimentary setup. It's not going to be great, but it's going to allow us to practice some of the math we've got. All right, now in class, I surrounded this thing as much as I could, kind of with a heat shield, with some aluminum foil, to try to funnel a bunch of heat up to here, because clearly, like, can I guarantee when this is burning, all the heat's going to go into this can? No, but we'll do what we can. So we'll at least try to compensate for heat loss, our major source of air in this experiment, a little bit. That'll work. All right, I'm going to take this out before I light it because I don't want any of the heat from the lighter to go ahead and heat up my water at all. There we go. All right, I'm going to give this about 60 seconds, and then I'm going to go ahead and blow it out. While it's going, I'll go ahead and stir this water a little bit. Try to contain your excitement, please. It's embarrassing. Trying to be careful here to make sure when I take my final temperature that I'm not touching the can at all. I want to just make sure that I'm hitting the water. Heating up, we're at 31 degrees Celsius. You know what, I'm going to call that about a minute. All right, I'll stir this for a little bit longer. Let's see what the highest temperature we reached is. I don't know if you can see it, but I got 31.5. It went down very, very quickly, but trust me, it said 31.5. So I'm going to go ahead and record that over here. And I'll switch screens for a second. All right. Let's go ahead and see if this thing worked. This should have dropped mass a little bit. Okay, we have 169 0.90 grams. All right, so we got a drop there. That's not so bad. All right, so that covers our ethanol trial. We'll be able to do some math, do some calculations, and answer those questions on back. And now we got to switch over to a chip trial. We'll see if I can get 2 done. We may have to just base your information on 1 because I have a little second grader I need to go pick up after school. All right, so we're going to go ahead and we're going to burn some chips. I've got some tortilla chips here. If I remember correctly, the nutritional information was it was something like 150 calories per 28 gram serving. That's going to be important as we answer some of our questions on the back. 150 calories per 28 grams. It looks like it's a little hard to see. All right, there we go. All right, so these are the chips I'm going to burn. I'm going to go ahead and determine the mass of my watch glass and chips. Watch glass is that little round glass thing under there, mostly to catch any pieces that fall off during the burning. All right, mass of calorimeter plus water, that should not have changed. I'm sure a little bit of water evaporated, but not too much. It didn't get that hot, 31.5 degrees Celsius. Okay, what is my initial mass? 29.86 grams. All right, let's go ahead and see how warm this water is. Now, it would be best if we let this cool all the way off, but that's not going to happen. All right, I've got 30.6 degrees Celsius. Oh, I see it sneak up to, we're going 30.6. So my initial temperature, 30.6 degrees Celsius. I'll go ahead and burn that chip. Then I'll measure the temperature of the water, and then I will weigh what's left over, and we can see that the change in mass is going to be, well, the amount of chip that I burned. Pretend like you didn't see that. Oh. All right, I'm gonna have to open this up a little bit more than before so that I can hold this chip in there. All right. I'm gonna go ahead and get this alcohol burner going so that I can use it to light my chip in just a second. All right, so we started out at 30.6 grams. I'm going to try to hold these little chips here in the tweezers. I'm going to get them lit pretty quickly, and then I'm going to move them over here under this guy. Smells like burning chips. A lot of calories in those little chips. Got a lot of oil in them, and that's pretty flammable. Probably why we don't eat them when we're on a diet. Clearly, it's not very clean burning. I don't know if you can see the black smoke from there or how this soda can is starting to change color. Just getting covered with soot. So that would just be solid carbon. Guess that's why we don't burn chips for energy. Oh, it's getting pretty hot. We're at 45, 46. Okay. Gonna go ahead and set all the pieces on here. I'm getting a high temperature of 46.7. Are we going to 46.8? Are we going to get any higher? Looks like 46.8 is going to be our maximum temperature. 46.8. I'm going to go ahead and scrape some of the little bits of this chip off. Back onto the watch glass, and let's go see how much this guy weighs. Said 46.8, didn't I? I hope so. I'm sure you were writing it down. You're a good student. All right, so we said the highest temperature was 46.8 degrees. That's a pretty good temperature increase. On the mass of the chip now, I've dropped down to 28.41 grams. So we definitely lost some mass, and so we can see how much energy was contained in that 1.45 grams. Now, normally, if I had more time, this would be much better if we could do a second trial and average some of the data. I'll come back and give you some of that data when I post this lab out there, but I don't have time to do it right now. Because there's such a great source of error and there's so many different variables and everything else going on there, it's always best in science if we take multiple trials and average our results. But as they say in my kids' preschool, sometimes you get what you get and you don't throw a fit. All right, have a good one, guys. Talk to you later.